Today we will talk about electronegativity. Electronegativity is when you have a compound like HCl and it's the ability for an element to pull electrons in a bond to oneself. So some elements are more electronegative than others, and to figure this out, you have to look at a periodic table. Remember that noble gases won't have any electronegativity, and we will talk about this later. But if you go right across the periodic table, you will have a more electronegative element. Also, if you go upwards across the periodic table, you will have a more electronegative element. So fluorine, which is the furthest to the right and the most upwards, will be the most electronegative element. There is one exception to this rule, and that is that the electronegativity of a hydrogen will be between boron and carbon, which means that it will have a higher electronegativity than boron, but a less electronegativity than carbon. So we can try some examples, and feel free to pause the video and try these yourself. So for the first one, for fluorine and bromine, you can see that fluorine is more upwards across the periodic table and will have a higher electronegativity. For oxygen and carbon, you can see that oxygen is more to the right and will have a higher electronegativity. For carbon and hydrogen, you can see that carbon is just slightly to the right of hydrogen and will have a slightly higher electronegativity. For selenium and phosphorus, you can see that selenium is more to the right of the periodic table, but phosphorus is more upwards in the periodic table. So which one will have a more higher electronegativity? You will never be asked this kind of question on a test, and you will need this kind of periodic table where you have all the electronegativities listed. And you can see that selenium is actually a higher, more electronegative than phosphorus. So you actually don't have to remember all these numbers, but you can see that the trend is the same where if you go to the right of the periodic table, the numbers are higher, and if you go upwards, the numbers are higher. Additionally, you can remember the mnemonic Franco-British. Franco-British gives you the order of electronegativities from highest to lowest of common elements. So fluorine is the highest, oxygen is the second highest, nitrogen is the third highest, and so on. So like I said before, some elements are just more electronegative than others. Remember, the main goal of all elements is to be as stable as possible, and this is why they make bonds like fluorine and carbon. However, some elements in a bond are simply just stronger and will pull electrons much easier. Also, this is why noble gases like argon don't have electronegativity, and it's because they're already stable. This is why noble gases don't make bonds with anyone and they don't really need to pull any electrons. You can think electronegativity as a tug-of-war contest. In a bond between fluorine and carbon, fluorine will easily beat carbon as it's more electronegative and will take all the electrons or pull all the electrons from carbon. In a contest between hydrogen and carbon, it will actually be a tie since their electronegativities are so close to each other. In a compound, when an element is more electronegative, it will have a partial negative charge. So you can relate electronegativity to polarity. When you take the difference of electronegativity between two compounds and is less than 0.5, it is said to be a nonpolar compound. But when you take the difference of electronegativity between two compounds and is between 0.5 and 1.7, it is said to be a polar compound. Lastly, when you take the difference of electronegativity between two compounds and is greater than 1.7, it is an ionic compound. So if we look at these two examples, if you look at these examples, you can see that the electronegativity in a bond between hydrogen and carbon, the electronegativity of carbon is 2.1 and the electronegativity of hydrogen is 2.1. So the difference between them is 0.4, and since it's less than 0.5, it is a nonpolar. And you can do this with all the other compounds. For carbon-carbon, it will be nonpolar. Oxygen carbon, since 3.5 minus 2.5 is 1, it is polar. And then for nitrogen and oxygen, it's 0.5, so it will be polar. And then for Na and Cl, it will be 2.1. So it will be an ionic. And then lastly, for magnesium and bromine, it will be 1.8, will also be ionic. Also, I want to note that this rule only works for compounds with only two elements like these ones right here. It gets complicated when you have more elements.